We wanted really a controlled environment in which we could take a drone to a certain height and a certain location and relative position those two drones, and then have relative movement between those drones and understand how to get them connected with each other and communicating well. My name is Joe Camp, and I'm Associate Professor of Electrical and Computer Engineering in the Lyle School of Engineering at SMU. We're creating a safe place for drones to be in flight. One of my students brought a drone to Taos, New Mexico, where I was teaching a class, to get a feel for the type of environment that we were in, how many trees there were, how dense those trees were, how much of an elevation there was, and all of those things affect wireless behavior. And I started thinking about, well, there's a lot we could do with drones in terms of understanding wireless environments. DARPA was putting on a Hackfest in which they would take programmable wireless hardware and communicate to a drone and control the drone. I took a team of 3 students who had been with me in Taos. They were giving us a very open, unrefined wireless channel and wireless model to use and to control the drone, so the likelihood of a crash was very high. We're the only team with 2 successful drone flights. And so when we came back to Dallas, I was thinking, wow, I can fly drones pretty well in Taos, but we really wanted a space in Dallas where we could fly drones. I wanted this so bad to have this facility to do controlled drone communications research. I could almost taste it. Like I knew that would be a good thing for our research group to have. In addition to all those kind of roadblocks, there is the curiosity that we had of around a flyable space, like where you're flying. What is the wireless behavior that's emitting off of the drone? The mobility of a drone as compared to a mobile phone is far more severe. You don't have a 3-dimensional problem where one phone is trying to transmit to something that's multiple feet below it or tens of feet below it. And you don't have this problem of at any point in time, one device could be above another device or below another device. How do you get drones connected to each other? Can you handshake with another drone and tell relative position to each other? Are they moving toward each other? Are they moving away from each other? There are a number of different limitations that drones have on them that make them interesting, but there's only so many radios you can have on the device, and there's only so much real estate that you can have on the drone, and there's only so much power that you can power each one of those radios as well. You're not just building a program that's running on a high-performance server, but you're building code on small devices that don't have a lot of resources. So we were relieved to find a place that would work for us. However, it looked very different than it does today. This building had a metal roof and you could not get GPS. So we had to come up with a solution for localization. We've now installed 8 different anchors that are on 2 different heights on each of the 4 corners of our flyable space. And it functions very much like a GPS system. It's triangulating off of those 8 anchors that are transmitting, and the tags that will be on the drones are getting the reception of the channel quality between the tag and the anchor, and then computing the position in terms of X, Y, and Z, so 3 different dimensions. The hardware that we need to measure wireless behavior around this space normally was in a server rack as opposed to around a very large space. So we had to come up with a solution for that. The wireless programmable platforms had only been in an air-conditioned, climate-controlled environment on a server rack. And so we're trying to do something that they had never been engineered for. But as we went close to the metal roof and it was outside of the spec of what a reasonable operating temperature was, we ended up having to slightly air condition the space so that we could bring the temperature down. We need to keep the students safe, and so we had to find very large nets that would cover the space. We've set up 72 different receivers so that we can monitor the behavior at different points around the netting, and as it relates to the wireless transmission being transmitted off the drone, because the body itself mixes with the antenna, and it becomes a system of itself. There were a number of these challenges that put up roadblocks. Through the course of this project, there's been this coming back to this vision over and over so that we can get to this place that we want to be. So each one of those 18 software-defined radios that are on the wall, they need to have an ability to clock with each other. So in other words, they need to have the same notion of time. However, they're distributed in space. And so every clocking system was only valid in a server rack setup. And so in other words, in a very small space. But we're having runs of 150 feet across the facility. And so we had to investigate a new solution, which turned out to be a fiber clocking solution, where you have this white rabbit switch where you're clocking over hundreds of feet. And so we now have the ability to clock each one of the 18 software-defined radios back to the server rack, and they all have the same notion of time. In addition to that, when you are characterizing wireless channels, there is a huge amount of data that needs to be logged. When we were originally running the cables, we ran two different types of cables. One was for command and control, that was an Ethernet connection, and one was this fiber clocking solution. We came to realize that the speed of the hard drives of each one of these software-defined radios was not nearly fast enough to log things locally. It was much faster to have a fiber connection back to servers to distribute that load. Now the next wave is getting to the point where we can take multiple drones and act as a single transmitter from multiple drones to increase the number of antennas to replicate these large-scale systems that are being formed today for cellular and Wi-Fi. But now for drones, you could potentially have a drone swarm that becomes a transmitter with very different shapes. The different shapes would affect the wireless transmission properties, whether you're more concentrated in nature of the directional nature of what you're transmitting at, or is it a more broad beam that you're trying to have at your receiver. There's research challenges even within this facility in this project. I want to inspire students to go deeper, and the way to do that is to create curiosity in them. Moving forward with this facility, we have planned over the next month to bring in a robotics team of 30 students from K through 5 to come and see a robot that's flying in the sky. We're trying to plant seeds in the younger generation to get a vision for this and to come after us and do greater things in other places.